Thank you, Katie, for the introduction. Hello, everyone. As Katie mentioned, my name is Ariane, and I'm the product manager for Vention's Machine Builder and MachineCloud. I joined Vention about 3 years ago and started as an application specialist. In that role, I worked extensively with our Machine Builder software and designed thousands of custom automated equipment for over 300 clients across the globe. These clients were in the automotive, aerospace, defense, medical, and food and beverage industries. So, working directly with manufacturers in various fields really allowed me to get a deep understanding of their realities and create unique solutions to solve their manufacturing challenges. This experience really ties in well with my current role as a product manager, which consists basically of gathering and prioritizing customer needs to improve products and plan out product roadmaps. So today we'll be covering various topics on how you can automate your factory floor through a single digital manufacturing automation platform, which I will refer to as MAP. So here's a highlight of what you will be learning today. First, I will cover Vention and answer your burning question about what is a manufacturing automation platform. I'll also discuss certain trends and how they have been impacting manufacturers in North America. And most importantly, we will deep dive into MAP with a platform demo. So I'll be covering design, automate, order, and deployment steps, and highlight our latest tool, MachineCloud, that allows step-by-step machine deployment from a digital twin and real-time machine monitoring. The session will be followed by a Q&A where myself and Justin McLeod, our product manager for Machine Logic, will be taking your questions. So, our mission here at Vention is to democratize industrial automation with a self-serve platform for high-mix manufacturers. And by self-serve, we mean that our users, which are usually manufacturing practitioners, can design, automate, order, and deploy by themselves. They are high-mix manufacturers in a sense that they have small production volume and historically could not afford to have profitable industrial automation projects as a result of that smaller volume. One thing that I like to emphasize in our mission statement is the with confidence. For us, this means that whatever is going to happen online or in the cloud before our users have to commit to any kind of investment will translate one to their factory floor afterwards. So, a few facts about Vention. We were founded in 2016 and will be turning 7 years old this year. We have three offices, one in Montreal, one in Berlin, and one in Boston. And we have over 14,000 machines in the field and serve over 3,000 clients in North America and Europe. So, we're going to talk a lot about democratization today. And in fact, this picture that you see here really represents that. It represents democratization, but also represents labor upskilling. Stephen Gell is one of our clients from 2018, and the machine you see behind him is a fabric cutter. He actually designed and programmed the machine by himself. So Stephen was a maintenance technician, and now he is an automation practitioner, while in the past he couldn't do any of those things by himself as he had to hire a system integrator. But now he can because we've made the technology easy enough for him to understand and do beautiful things. Don't get me wrong though, Stephen already had all the process expertise and manufacturing expertise to know what the machine should do. The complexity behind the technology was limiting his ability to create value for a business, but that's no longer the case. When we think about industrial automation, we think of the picture on the left, right? We see a car assembly lines, consumer electronic assembly lines where there are robots everywhere. I would claim that this problem has been solved. There are good incumbent traditional players in manufacturing automations that do provide solutions for that type of problems. The reality is, most of the world is exactly like the picture on the right, where you have manual or semi manual assembly lines with workers doing the same task over and over again. And in fact, 80% of the manufacturing sites in the United States are exactly like that. We have very little to no automation. The main reason is simply because it's not profitable for them to automate. The blue curve that you can see here is basically the type of payback you can achieve based on your production volume. If you're a high mix manufacturer, you always want to have a payback below 1 year because you don't know how long your client contract will stay with you. They do change quite often. So let's take the example of 500K project. If you unpack that project, half of the cost will be for the technology, usually coming from incumbent manufacturers of industrial automation providers. The other half usually goes to the system integrators or the engineering work that is needed to design, program, and eventually deploy those systems. What Vention does through our democratization technology is to eliminate the second half. So this shrinks the project cost and by default enables manufacturers to automate profitably. In the context where there's a looming recession, there's no better solution than this. Manufacturers that are still facing labor shortages, yet are still seeing lower demand, can now solve both. They can reduce costs with automation and do it by themselves. With technology like Vention, we end up in a world where folks that used to operate the manufacturing floor are becoming the folks that will now design the manufacturing floor. This is exactly where our founder and CEO, Etienne Lacroix, started his career. He was a young and eager engineer working at GE in Montreal, and he was designing those automated systems on CATIA or SolidWorks. Every time he was starting a new project, he would go see his client and they would give him a statement of work, a big binder with hundreds and hundreds of pages, defining all the requirements they wanted. He would then go on industrial distributors' website to find some vendor parts, hoping for the 3D models to be there. Sometimes they were, sometimes they weren't, and he would then end up recreating all the parts from scratch on his 3D software. He would soon realize that all those vendor parts use standards, but all different ones. So then he would have to design all the custom parts that are needed to connect the vendor parts to one another. Frame, brackets, mounting plates, sheet metal enclosures, the list goes on. So as Etienne would progress on his 3D design, he would probably ask one of his colleagues, an electrical engineer, to start programming the machine using PLC programming software. During that time, he would create 2D drawings for all the custom parts that he had designed with the intent of getting them manufactured. His procurement team would probably issue an RFQ, a request for quote, and get a manufacturer to produce the custom parts. Eventually, he would receive them and start assembling the machine, loading the software, and start his factory acceptance test. Only several months later, he would go to his client delivering a fully functioning machine. This whole thing is a project and it takes months to complete because most of the tasks here are manual. They shift from one environment to the next and move data from one data set to the next. In fact, there's nothing more manual than industrial automation until we've put Vention together. So let me describe how Vention works today. We define ourselves as a MAP, Manufacturing Automation Platform. We're based on 4 pillars and 4 capabilities. We start with design. Our users arrive on our website and fall into a software that we call Machine Builder, where they can design with industrial Lego bricks. In that environment, we have all the geometric data and the metadata of all of those parts, prices, weight, description. So equipped with those 2 data sets, we can do beautiful amount of software automation that would never be possible in a traditional CAD software. We give our users real-time pricing, assembly time, automatic bill of material, and automatic fastener management. We can recommend the next best part for their design, fetching in a library of over 200,000 designs that our team and clients have created. When we bring one part to the next, we can predict how the user is trying to connect those 2 parts together. This whole infrastructure that we've built, leveraging the geometric and metadata, just makes the act of design significantly faster and easier. When we're done with the design, we have this working prototype. It's time to automate. Our users can program their machine in a visual sequence editor online and simulate. They can simulate not only traditional automation, conveyors, pneumatics, actuators, but also robot arms. If they like what they see, they can move on and order their machine. Once they order their equipment, they get it in an IKEA style packaging, so flat pack boxes, so they can assemble by themselves using a single tool. Since Vention controls both the hardware and the software ecosystem, we make sure that from the ideation to the deployment phase, the user experience is extremely seamless. And then it's time to deploy. If we want our Stephen Gale to be successful, we can also help him here. Keep in mind, we have a perfect digital twin that was created during the act of design. Equipped with that information, we're able to create tailored step-by-step deployment instructions for our users. Some of you might have a Sonos in your home, and you might remember the complexity of connecting them to one another and pairing them. There's a little wizard that assists you through those steps when you initially deploy your Sonos. So we've created something very similar called MachineCloud that does the exact same thing, but tailored to the custom machine that our users are designing on Vention. So as you're going to power on your machine motion, we're going to make sure that all the sensors are present, that the motors are turning in the right direction, and that the bounding box of the machine can operate collision free. We're doing all the checks that a qualified system integrator would do, but we're putting that tool in the hands of practitioners directly. And we'll do a demo later on MachineCloud, so you'll be able to see this. So if you think about all the digital integration we've built with MAP, we significantly shrunk the time it takes from ideation to deliver a design. We're talking about a couple of days, a couple of weeks max. We're not talking in months. If you look at where the value is created, the cost saving through digital integration will really come from the engineering tasks, what we call the system integration cost, the act of design, the act of programming, the act of deploying. All those manual tasks will take significantly less time. And on average, we see our users going 5 times faster than the traditional ways of doing industrial automation, and that translates roughly to 40% less cost. This contrasts quite a bit with traditional players in the fields such as PLC-based technologies. These are targeted for high-throughput manufacturers, car assembly lines, consumer electronics, when MAP, in contrast, is geared towards high-mix manufacturers. It's simple, it's self-deploy, and consequently, we can target all manufacturing professionals. Instead of talking about cycle time, throughput, and precision, we talk about ease of use, next-day shipping, and self-deployment. Again, for project duration, we'll talk in days, not in months, and payback will be significantly lower for our client, even though they are high mix manufacturers. It's a very, very different way to approach industrial automation compared to how the world has been operating so far. In the past, everybody loved talking about labor shortages and inflation. All those trends are true. As manufacturers, I'm sure you all live those realities and are still affected by them to this day. On top of that, there's even a more profound change happening in our industry, which proves that moving to democratized technology is the path forward. If you remember that story of Etienne, our CEO, back when he was an eager young engineer, a car platform had a 7-year shelf life and a consumer electronic product was around 36 months. Today, a car platform has a maximum shelf life of 3 years, and consumer electronics can be outdated in 9 months. If your product life cycle is shorter as a manufacturer, your primary concern is not having the highest throughput, but having the fastest deployment possible for your manufacturing system. So if you can have your manufacturing system operating in 2 weeks as opposed to 6 months, you have just increased your product life by 4 or 5 months. This usually translates into significantly more value than the cost of the equipment itself. Hopefully, labor shortage and cost pressure will be resolved within a couple of years, but product life cycle is unlikely to get longer. This trend is here to stay. Consequently, when considering deployment and the value of time when deploying industrial automation system, will lead to an increased benefit for our end users. So moving along, let's look at a couple of designs that were done by our user base. You'll see here, they're all different, they're all custom. All of you here on the webinar today are probably manufacturing end products that are specific to you according to your own manufacturing strategy. So if I take the operator on the top middle picture here, this is a company manufacturing natural gas meters. You probably have one of those inside your homes if you have natural gas. So this company decided to have inline testers with 3 test lanes. Why? Because this is a custom unit specific to them, and it's mostly because they're producing in batches of 3 and they wanted to have that flexibility. This is not a machine that can be found in a catalog. It's specific to them. And right under that same picture, you have an assembly jig that is currently at the Tesla facility in Fremont. This is to inspect the hood of Model S cars. So again, very custom to them. There's no jig like that exists beyond the ones that you see here. And that is the beauty of MAP. It gives you the ability to go really fast, but yet keep a lot of flexibility provided by the modularity of our ecosystem. The last thing I'll talk about today before we go into our product demo is how we're looking at applications. For us, applications live on top of our platform. We're providing users a tremendous amount of hardware building blocks, but also software building blocks. Those can be grouped into kits that have a defined function: palletizing, conveying, gantry robots, range extender, and so on. With our own platform, we create applications which provide us starting points to our users so they don't have to reinvent the wheel. So the benefit for the end users is that those applications leverage the same field tested and software tested Lego parts and software. This doesn't feel like an integrator project. It feels like a product that has been deployed in a repeated fashion that has a track record of performance. There's around 18 currently that you can find on the Vention platform, and we are releasing new application every quarter or so. All right, so now we will proceed to our platform demo. So let's jump right into Vention.io. So as you can see, this is our homepage. From here, you can create your own Vention account, and then you'll be able to start designing by simply clicking on this top right corner button, Design Now. You can start by giving your design a name. So in this case, I'll just put Vention Workstation. I can choose a category. So I can choose workstations under industrial furniture. I can add a little description here, and then I can add any collaborators if I know that multiple people will be working on the same design. Once that's done, I can start designing by clicking on Start Designing, and it will bring me directly to my Machine Builder page. On Machine Builder, you'll see on the left side, you have the parts library that's going to hold over 1,000 industrial automation components that you'll be able to access and design with. On the top here, you have a menu full of different tools and features that will allow you to design quicker and more efficiently. And on the right side, you'll see here you have the price, the assembly time, and the weight that will get instantly updated every single time that you insert a component into your design. So for this demo, we're going to be designing a workstation. It will be for an R&D cell. So let's start by building the frame. So I'm going to go under structural and framing, and you'll see I have access to different profiles of extrusions. I'm going to go with the 45 by 45 millimeter standard extrusions that we have. I'm going to drag it and drop it directly into my design. As you can see here, I can resize it as much as I want, so I can make it a bit longer, a bit shorter. And once I'm happy with it, I can reinsert another extrusion. I can either reinsert it by grabbing it directly from the parts library, just like that, or I can also use my keyboard shortcut, so the I button, and it will reinsert the last part that I inserted. So now I have an extrusion. I can snap it to my other extrusion, and I'll do the same thing on the other side. Now let's say I want to make these two a bit longer so that my workstation is a bit longer in length. I can select both extrusion and I can resize them at the same time. Now that I'm happy with it, I'm going to go close off my rectangular frame. As you can see, these extrusions connect to each other in Machine Builder, but in real life, I would need some kind of connector to keep them attached to each other. So if I press on the extrusion, I have this nice feature called Next Part Suggestion. So Machine Builder understands that you want to connect these two extrusions together, and it will suggest parts that will allow you to do so. So in this case, I have a gusset, perfect for this application. I'm going to click on it, and I'm going to insert it right in the corner. You'll see also I have an autocomplete feature here. So Machine Builder understands that this is a closed frame and that you'll probably need extrusions in the four corners. So it's going to suggest that you autocomplete the frame with gussets in all the corners. I can just click on Control and press, and then you have the four gussets. Also, as you can imagine, the gusset here will attach to the extrusions through T-nuts and screws, and those although they don't show up in the CAD, will be automatically included in your bill of materials. So you really don't have to worry about any fastener management. It's all included in your order automatically. So now that I have a nice top to my workstation, I'm going to go add some legs. So I'm going to grab these extrusions here, add some legs to the four corners, and then I'm going to add some feet to this workstation. So I can go back under frame accessories. I have a nice selection of different leveling feet. I'm going to go with this one here, and you can see it snaps directly at the bottom of the extrusion. Now, I agree, my workstation looks a bit short. I'm going to make it a bit longer, so I'm going to select the four legs here, right click, resize, and you'll see my feet will also follow with my resizing. Once I'm happy with this frame, again, as you can see here, I have a floating extrusion here. I need some kind of connector, so I can use, again, my next part suggestion, or I can go back in my parts library and choose a plate that I prefer. So in this case, I'll go with the L-shape brackets, and I'm going to be putting them in the four corners here. There you go. So my frame, everything's holding. I have connectors, I have extrusions, I'm missing a top. So we have a nice selection of panels. At Vention here, we have plastic panels, different types of plastic. We have aluminum panels, stainless steel panels. In this case, I'll just go with a normal HDPE panel, and I can drag it and drop it directly on top. Machine Builder will understand that this is the surface that you'd like to cover. You can confirm, you can go in and change the color as well if you'd like. You can change the thickness, and you can add some automatic mounting holes. So as you can imagine, the panel will need to be attached to the frame. And so Machine Builder will create these automatic holes for you so that you can attach it through T-nuts and screws. Again, this custom panel with the holes will come with your order, as well as all the fasteners needed to attach it. So now that I have a nice workstation, let's say this is for an R&D application, and for my research, I need a linear actuator. So what I'm going to do is I'm going to go back into my categories, go under linear motion, and from here you can see that I have multiple different types of actuators that I can choose from. I have enclosed ball screw, belt racks, enclosed timing belt, open timing belt, and so on. So for this demo, I'm going to go with a nice enclosed timing belt. I have different lengths that are available to me. So I can go with the 1.5 meter, for example. I drag it and I drop it directly in my design. So you see here that you have all the mechanical components um, for the enclosed timing belt, but you don't have the automation component. So you don't have you're missing the sensors, the motor, the controller. So you could drag them one by one from the parts library, but you can also use our nice configuration assistant in Machine Builder. So you can just right click on the timing belt, you click on configure, and you have your configuration assistant on the left here. It will walk you through the different components that are necessary. And you can choose, for example, here you have two different types of motors that you can choose from. You have your sensors, you have your controller, and you have your e-stop. You can go one by one, or you can just press on autocomplete, and this will allow you to autocomplete your design with all the components needed to automate your enclosed timing belt. So if I just go here, you'll see that you have the motor attached, you have the sensors on each side of the timing belt, you have your machine motion controller, so the brain of this automation cell, and then you also have the e-stop button for safety purposes. So as you can see, as I was designing, the price here on the right side was updating the assembly time and the weight. And if ever I choose to, for example, delete all of these components, you'll see that my price also updates instantly. Now, once I'm happy with my design, I can take a nice thumbnail so that when I'm on my dashboard, I know which design this is. And then once that's done, and I want to review my bill of material to make sure that I have all the components that I need for my application, I can just click on bill of material. Right here, it's going to bring me to the design page, and on the design page, you can click bill of material and you can go through all the different components. So as you can see, I was talking about fastener management. You'll see all the fasteners there. They don't show in Machine Builder, but they will show in your bill of material automatically, so you don't have to worry about them. All right, now that I'm happy with my design, let's automate it. So for the sake of this demo, our product manager, Justin McLeod, that you'll see later today during the Q&A session, prepared a nice 3-axis Gantt tree for us. So if I click on the Machine Logic tab here, you'll see I can go through 3 different steps to automate and then simulate on the cloud. So the first thing is I need to configure. In this case, I have multiple different actuators, and I need to configure them so that we know which one is the X, which one is the Y, and which one is the Z axis. So you can see whenever I configure an actuator, it will let me choose which actuator we want. So it's going to highlight it in green. Then I can name it. So in this case, this would be the X-axis. I can choose which motor is attached to it. And then I also choose which sensor is the home sensor and which sensor is the end stop sensor. Once I configure my actuators, I'm ready to create an application. So I'm going to create a new application here. You'll see this is a very user-friendly interface, code-free programming. So I can, if I want to, for example, home my x-axis as my first step to my sequence, I can add a command, add a motion, and then you can see I can choose the actuator um, that I want to home. I'm going to move it right here to home. And then I'm good with my first step. Now, if I want to move it relative about 350 millimeters, again, I choose my actuator that I want to move. I choose my motion and I can enter a value. So let's say 250 millimeters. I want to do one last step to this application. I want to rehome again my actuator. So I'm just going to move it back to home. Now you'll see we have a little warning here. So this is my application checker, just giving me a few warnings uh, that might be interesting to consider. So in this case, it's telling me that I need to set a speed for my actuator and I need to set an acceleration. No problem. I'm going to go back here. I'm going to add a command and I'm going to set my speed. So let's set it to 100 and I'm going to set my acceleration. I'll put it to, let's say, 150. If I want to set my speed and my acceleration before my actuator actually moves, I can also just click on this step and drag it right on top. Very, very simple and easy. I have no more warnings. This is good. I can start playing and I can see on the right side here, my jig is going to simulate what I just programmed in 2 minutes. And it does exactly what I want. Now, if we go into a more complex application, so we have this palletizer application here. You'll see Justin was able to create all of these more complex sequences. So he was able to use loop count. He's able to send messages to the console. He's able to insert wait event. One very nice new addition to Machine Logic is also Lambda function. So if I go under variables and functions, you'll see he was able to create these very interesting Lambda functions for his application so that he can create a better sequence for his application. So once I'm happy with my application here, I can go into my step 3 where I have a UI builder. So this is what the operator would see, and from here I can also modify my UI. So let's say this big button to start palletizing, I don't like it on the right. I feel like if it's in the middle, it's going to be easier to access. So I can just drag it and drop it right in the middle. I can always add some inputs and add any kind of buttons I want. I also have the modules here on the right. So as you can imagine, these modules in real life would be a physical module. In this case, on the cloud, I have them displayed and I can even push on them. So push on the different buttons here to configure them. So once I'm happy with the application, with the UI, I can test out my application. So I'm going to press on play here and you'll see it's going to start simulating. So now I have a wait event. So right now it's waiting for me to click on start palletizing. So I will click and it's going to start palletizing. And now again, I have another waiting event. In real life, it would wait for me to press on this physical module on the black button. In this case, I'm simulating it and I'm just going to click right here on the screen. And then we can start palletizing. So you'll see my x-axis is moving, my y-axis is moving, and my z-axis is going up and down to palletize. All right, now we've designed, we've automated, let's go through the ordering. So for ordering, I'm going to jump right into my dashboard where I have my different designs. And in this case, I would like to order, let's say, the Vention workstation that I just designed. So I'm going to go under my designs. I'm going to click on the Vention workstation that we all designed together, and I'm going to add it to my cart. I can get a design review if I'd like. I, I can skip it. So in this case, I'm just going to skip and add to cart, and I'm going to go to my cart. From here, I can continue to check out. So I'm happy with my cart summary here. I can add any add-ons. So if I need a tap, if I need some extra grease, I can always add it in this step. And then it brings me to this very secure and simple checkout. I choose my shipping information. I can choose a shipping method. I can always download my PDF quote if needed. And then once I choose my shipping, I can continue to payment. And then once that's done, I can place my order. So very simple, very fast, and very secure. So for the last 6 years, Vention has focused on democratizing industrial automation by easing the design, automation, and ordering processes. Vention built a platform that encapsulates the most comprehensive modular hardware ecosystem, intuitive 3D design tools, and code-free programming capabilities. But recently, Vention tackled the last problem of industrial automation, deployment, by linking the real machine and its digital twin. By leveraging the data of the digital twin of the machine already present on the Vention platform, users can now have access to a completely customized deployment flow, effectively eliminating the common hassle of hardware and software commissioning. And so let me introduce you to our latest deployment tool, MachineCloud. You can deploy your machine with step-by-step instructions that guides you from the digital twin in the cloud to the physical equipment in the factory. You can browse your MachineCloud dashboard to access your machine information in real time, and you can bring agile development to your machine operations and continuously upgrade functionalities and throughput. So let's go into a demo. So let's jump right back into that 3-axis gantry design that I had used previously for my Machine Logic demo. So as you can see, if I click on the MachineCloud tab on the top, it will bring me to the MachineCloud interface. From here, I can start the setup, and I will start with the hardware setup, where I can ensure that I have the correct tools. I can ensure that my bill of material matches with the different packages that I've received, and I have access to my assembly instructions that were custom made for my custom design here on the Vention platform. Once that's done, I can also validate my assembly with a nice checklist. And if I need, I have more assembly resources available here online um, for further help. Once I'm good with that, I'm going to click on next step, and this will bring me to the wiring checklist. So in the wiring checklist, I have my automated system diagram That's going to guide me through all the wiring necessary and where to connect all the different cables. If I have cable management, if I have light curtains, if I have safety modules, I also have some extra resources on this page for it. Now I can power on my machine motion and I can connect my pendant to the Wi-Fi. Once that's done, I'm going to start validating. So you'll see here we have a physical machine that's attached to this design, and I'm going to run through the configuration checker. So I'm going to check to see if my drives are correctly wired. I'm going to check the different motor direction. So you'll see my jig is actually going to move at the same time as I'm checking all of this. And I'm going to also verify if my homing sensor and my end sensor um, are placed at the correct position on my actuators. I can then see the test results. Everything is good, everything is green, and I can go to my next step. So my hardware setup is done. I'm going to start going into my software setup. So I want to deploy a specific application to my machine. So in this case, I'm gonna click and I'm gonna choose my palletizer app that we went through today. Once I choose the application, you'll see I have an application checker. In this case, I don't have any warnings for my application, so we're good to go. And I'm gonna go into my trial run. So we can run a trial of the application that we've chosen, and we can run it at, in this case, 30% speed, just to ensure that if ever there's a problem with it, we can stop it if need be. So I'm going to play my application in this case, and you'll see in real time, my machine will move and we'll go through the different sequences that I've programmed on the cloud. All right, so just for the sake of this demo, I stopped the application. And now from here, I'm ready to deploy the application. I just click on this button and it's done. The application was deployed from the cloud to the factory floor. And as you can see, within minutes. So as you can see, MachineCloud is a revolutionary next step in democratizing industrial automation. It is simple enough that anyone with applied manufacturing knowledge can use it, and intuitive enough that errors and miscalculations are caught along the way. Again, as you saw in the demo, you can deploy with software-assisted step-by-step instructions. So we went through the hardware setup and then the software setup. You can have access to your machine information in real time through our MachineCloud dashboard, and you can continuously upgrade your machine functionality and throughput by simply redeploying new applications through the same easy and quick flow that we saw today. It has never been easier to deploy from the cloud to the factory floor. We've simply made automation deployment quick and easy. So I hope that you now have a better understanding of MAP and MachineCloud, and we will now open the floor to any questions from the audience.